Level 1. The chalk on your board is not software. They are topological proofs of nonlinear information manifold convergence. You are 23 years old, living on a $46,000 stipend, and you have never written a line of commercial enterprise code. That is exactly why the lab recruited you. Level 1 is the doctoral researcher. The program spans 5 brutal years at an institution where prestige dictates funding: MIT, Cambridge, ETH Zurich, or Stanford. Your tuition is waived, your health plan covers the absolute essentials, and your city budget is a rigid equation. You stop modifying after winter because optimization cannot stretch a fixed variable. Your mandate is not to build applications, nor to engineer products that fit into quarterly corporate roadmaps. Your mandate is to prove how neural systems learn when data is sparse. You teach undergraduate discrete mathematics 2 mornings a week to maintain your funding, but your true existence occurs at the friction point where information theory and statistical mechanics collide. Level 2. Year 2 yields your first breakthrough, a narrow but mathematically elegant paper on high-dimensional gradient landscape smoothing. It is published in a theoretical journal and will accumulate 19 citations over the next generation, mostly from robotics pioneers whose engineering applications you do not track. Year 3 gives the dissertation its definitive geometry. You perceive the structural equilibrium of the algorithmic framework long before the formal proof materializes. The agonizing chasm between intuition and rigorous mathematical verification is the exact space you occupy. By year 4, you are presenting at a specialized colloquium in Zurich. There are 50 attendees in the lecture hall. 42 are career academics. 8 are corporate scouts. During the afternoon break, an unimposing individual hands you a card devoid of corporate branding, only an encrypted email address. He mentions your preprint on stochastic tensor networks, utilizing the word compelling, with the deliberate neutrality of someone holding back a massive hidden ledger. Level 3. You send an email that evening. The initial technical assessment occurs 2 weeks later. The voice on the line queries your understanding of non-Euclidean loss functions and whether your systems can maintain coherence when processing asynchronous, corrupt signal streams. You admit you have not tested this, yet you proceed. You possess no knowledge of the entity's corporate identity, its operational scale, or its ultimate objectives. You merely recognize that an external force has parsed your theoretical mathematics and deemed it worthy of engagement. Your defense is scheduled 7 months away. The minimalist card rests in your wallet, and you return to the whiteboard. What remains hidden from you is that you passed their primary filtering matrix months prior. The dialogue was never an introductory screening. It was a deeply evaluative stress test. There will be 5 subsequent technical sessions before the word compensation is ever uttered by human lips. Level 4. The offer materializes 3 weeks post-defense from an Apex systematic lab, DeepMind, OpenAI, or Anthropic, an elite research enclave that values a pure mathematical doctorate the way traditional institutions prize an elite operational pedigree. Your total first-year compensation package is calibrated at $450,000, comprising a $190,000 base, an $80,000 signing allocation, and a guaranteed performance equity incentive of $180,000. You calculate the trajectory multiple times, deposit the draft, and experience a brief wave of cognitive dissonance before transitioning into complete numbness. The capital has no structural precedent in your life. You are 27. The facility houses 30 elite researchers steering computational clusters that consume megawatts of power. The environment lacks open plan noise, corporate slogans, or performative collaboration. It is a quiet sanctuary of dual monitor arrays and handwritten notebooks. The ambient sound mimics an elite university library, but the operational velocity is entirely alien to academia. Level 5. Your primary objective is the discovery of hidden structural patterns within multimodal data streams, building an algorithmic edge that survives localized network Noise and decays slowly. Enough to warrant massive deployment. The conceptual definition is pristine, but the structural implementation is chaotic. You spend the initial quarter dissecting internal literature on transformer architecture limitations, localized predictive anomalies, and deep reinforcement learning failures. Your initial architecture memo takes 20 days to compile, detailing an anomaly detection framework leveraging real-time maritime transponder telemetry correlated against synthetic commodity flows. It possesses a localized efficiency metric of 1.6. You pitch the framework in 9 minutes. The principal researcher reviews the executive summary in 3, utters the single word redundant, and exits. You spend 48 hours locating the exact point where your logic collapsed, but you never find it. Your second memo approaches predictive latency in edge computing grids. The principal reads it and murmurs, intriguing. Level 6. The systemic architecture is permanent. Your individual contribution is transitory. At age 30, your total annualized compensation reaches $820,000, a metric you have entirely ceased tracking. What matters is the operational scale of your deployment. You no longer own an isolated algorithm. You govern an autonomous processing engine that coordinates across 60 distributed data pipelines, integrating 40 discrete models under a unified operational matrix. You did not construct all 40 engines. Several were initiated by researchers who vanished to competitive labs or returned to tenure tracks. You inherited their legacy repositories, verified their fundamental constraints, eliminated vestigial logic, and restructured the system from its core. This is designated as core optimization, though it frequently feels like digital archaeology. The defining constraint at this level is localized system saturation. Your optimal model possesses a strict data capacity threshold, beyond which its own output distorts the environment it attempts to predict. Level 1. The daily schedule is not physically destructive in the manner of traditional corporate hierarchies. You commit 65 hours weekly by internal obsession rather than operational mandate. The true pressure is entirely interior. 4 months can evaporate where every hypothesis you deploy fails to maintain its integrity during out-of-sample data simulations. The underlying information distribution shifts its regime, rendering your previous computational assumptions entirely obsolete, forcing you back to the foundational proof. You author an internal technical document for the annual closed-door research assembly. It represents the most sophisticated engineering you have ever executed. Yet no individual outside this facility will ever view its contents. A specialized executive recruiter contacts your secure line, offering a principal director seat at an autonomous logistics venture managing massive capital allocations. He asks what infrastructure you can replicate. You delay your response for 3 weeks before stating you're not prepared. You know what verification requires when the arbiter is real-world performance. Level 2. 3 years pass, bringing you to age 33. Your total annual compensation package is fixed at $1.5 million. Your core optimization engines run silently inside 12 global operational frameworks. You did not write the entire codebase, but you hold its complete functional dependency map inside your mind. You recognize which subroutines are structurally brittle, which are robust against network anomalies, and which depend on infrastructure, variables that could evaporate with a single infrastructure update. Committing this structural map to a single physical document would trigger an immediate security protocol from internal compliance. The non-disclosure renewal occurred last winter within a secure, glass-walled conference suite over 3 intense hours. Every line of repository code, every optimization trick, and every predictive engine you have materialized here remains, the absolute property of the enterprise. If you resign, you face a mandatory 2-year global non-compete constraint across all computational automation sectors. Level 9. The systemic intelligence does not exist within individual algorithms. It exists within the overarching integration matrix, the precise layer where multiple model nodes communicate through a unified risk architecture across evolving data environments. You are finally permitted into the closed Sessions where this core integration layer is modified. The managing director approaches your workstation on a quiet afternoon, indicating an independent server cluster is being provisioned, specifically for your proprietary framework, offering a 10% allocation of optimized efficiency gains. You analyze the system architecture for 6 consecutive days, searching for a fundamental flaw you cannot resolve. Finding none, you accept the deployment. At age 36, you command an autonomous infrastructure, running on $900 million of computational resources. The daily terminal update is a cold verdict on your structural logic. You realize your machine is real. The outcomes are tangible, and the work is significant. Yet, you also understand it is merely a local approximation of a global computational matrix designed to outlast you. You return to the keyboard,